Welcome to Kafka Summit Europe 2021. I am Tim Berglund. I run the developer advocacy team at Confluent, and I'm also chair of the Kafka Summit program committee. Now, it's not quite time to start meeting in person again, but you know what? Streaming these things is working out all right. Kafka Summit 2020, that was last August, was fantastic. And so many people got to be a part of it who wouldn't normally have been there. And hey, here we are today. Now, as usual, I want to give a huge thank you to the program committee. So many people put in work to make an event like this happen. But the program committee, they went through almost 400 proposals, rated them all, and frankly, they were so good, we had to develop a new scheduling system to fit in all the content we wanted to share. At least that was our approach that we took. So be sure to be present during the live event so you can ask questions of speakers. But for any talks you can't attend, or if you can't be there live at all, you can still stream them online after the conference. Now, I'd like to kick us off with our opening keynote from Jay Kreps. Jay is, as you may know, the co-founder and CEO of Confluent and one of the co-creators of Apache Kafka. He's been using this phrase, data in motion, and I think it really captures what Kafka is all about. Listen as he talks about current trends in software architecture, the demands businesses and consumers are putting on systems, and why complete, fully managed platforms are likely the data infrastructure of the future. So, welcome to the virtual stage, Jay Kreps.
Hi everyone, welcome to Kafka Summit. I'm going to be talking today about making Kafka cloud native, and I'm going to be talking about the intersection really of two trends of the rise of Kafka and data in motion, as well as the rise of cloud and cloud native data systems. But to introduce and motivate these two things, I want to talk about an idea that I think drives all of this. And this idea is that in some sense, companies are becoming software. And it sounds a little funny to say this. What do I mean? I mean that in some sense, software is going from the outside of organizations, the kind of email and expense tracking and whatever else, the little apps you interact with, and it's moving right to the center of how businesses transact with their customers, how they carry out what they do. It's becoming the kind of central infrastructure that runs a business. And this is happening at the front end in terms of how companies interact with their customers. Increasingly, the best of breed consumer technology companies have set the bar for the customer experience that every consumer in the world expects. That they want the personalization, the omnipresent interaction that a Netflix would provide. They want all the capabilities of the company at their fingertips, wherever they are, on whatever device, everywhere. And it's not just the front end of the interaction that is going digital. It's the back end of companies. It's how companies manage goods, how loans are approved, how the streams of data coming from machines and orchestrating the activity of companies is happening all the time. And both of these are really moving into software, and this is really at the heart of how business operates. And there's a whole set of trends, I think, that enable this. So we're all aware that we now have a supercomputer in our pocket that is connected to the internet all the time. And this isn't just mobile phones, it's cars and other devices that are connected all the time and allow experiences that are everywhere. It's the rise of a set of applications which use data in a whole new way and extend the decision-making ability of software into new domains. It's the rise of new architectures for software systems that allow us to scale software engineering and connect applications across different domains. It's the rise of the Internet of Things, the ability to take streams of data from out in the world about what's happening in the analog world and represent it in software systems and allow us to act on these. And it's about the rise of cloud, the ability to harness computers and networks around the world any time of day on demand. And then what this talk centers around, the rise of data in motion. And so I'm going to talk really about these center two. about the rise of data in motion and how that projects out into the world of cloud and cloud-native data systems. But to explain data in motion, I'm going to start with the idea of data at rest. When we think of data and the infrastructure for data, we think of databases. This is a category that has been a platform for virtually every application for decades. It's received huge commercial investment. It's received huge intellectual investment. Virtually every university in the world, if they have a computer science department, is doing research on how to make databases better. But even though there's 101 different varieties of database, they all share a fundamental assumption. They're all built around the idea of storage. They come up out of heritage of storing data and providing an individual application access to little bits of that data. They take care of a little pile of data and allow you to process and access that a bit at a time. They're ultimately built around the idea of data at rest. And while this has been hugely successful in supporting applications, it isn't the only problem that companies face anymore. Increasingly, this kind of software-defined company that I described, to be able to provide these rich customer experiences, to be able to run the back-end operations continuously and in real time, this cuts across the boundaries of individual applications. It cuts across infrastructure silos. It allows really tapping into all the data and systems that a company has all the time and in real time. And this is incredibly hard to do with the architectures that we have today. If all you have is data at rest, then inherently you have little piles of data sprinkled all over the organization, applications that access that, different SaaS layers, data warehouses, analytics systems, and then a hairball of intertangled integrations between all of these. The kind of bubblegum and duct tape that holds it all together. And this is really no basis for moving to this much more dynamic, much more holistic software-defined world. And this is a problem that every company faces, and this is what has driven the rise of data in motion. And data in motion is what we're all here to talk about. This is what has driven the rise of Kafka. This really takes the paradigm for data management and kind of turns it on its head. So instead of having data that is in a pile that sits in one place and bringing a query at a point in time to look up a little bit of data from that pile, instead now data is flowing continuously. All the sales and the shipments and the customer experiences, all of these are generating data all the time. And the idea is to be able to process that real-time stream as it occurs, derive new data sets off of that, and be able to use that as an integration point to all the different systems so that we can take this big, messy, intertwined picture and turn it into something much simpler, into something where there is a central nervous system that all of these applications and systems tap into and get the continuous flow of events of what's happening in the business. And I think this is really the only possible approach to being able to scale across a company and being able to bring all these different systems together in a way that truly decouples them, that allows us to move quickly across these different pieces. And this is this larger journey of data in motion, and there's a ton happening in this space. I'll touch on just one thing you can learn more about over the course of this conference, which is KSQLDB. And this is actually bringing together data in motion, the real-time event streams, with the idea of data at rest. And this brings together what we think of as the mainstay of databases, tables of stored data, the state of the world as it is right now, the ability to look up the values for different keys with the real-time streams of events, what's happening in the world right now. And it turns out many of our use cases are about bringing together the state of the world and what's happening in the world, and doing that dynamically and continuously. And this is exactly what KSQLDB enables. It allows stored data, where you're doing queries on top of that to look up bits, to interact with active data, where it is flowing through the query that's predefined. And this means that you can build a complete streaming application end-to-end, from capturing events, performing continuous transformations on that stream of events, creating materialized views that combine stored data with event streams, and then doing dynamic lookups from an application against that materialized view. And it's an incredibly powerful basis, and I think serves a really important role as we start to have a huge volume of what happens in a company flowing as real-time streams through a system. So that's a little bit about data in motion. Now I'm going to talk about cloud, and then I'll talk about how these two things relate. So as we think about cloud, I'm going to really focus on this idea of cloud-native data services. And the reason this matters, I think as we all know, is there's this huge transition happening where over $140 billion in IT spend is going to move to the cloud in the next few years. And that's a massive shift. But it isn't just a matter of taking the servers that we have on premise and getting new servers that we rent in a new location. What this really enables is a completely new type of data system that's available as a service. I think this is a really transformational change. And it's been around for some time, really since the birth of the cloud, but there's a whole set of attributes we would associate with this. I think when we say cloud native, it's not exactly precisely defined what that means. And it's a little bit buzzwordy, but there's a whole set of attributes, the ability to scale elastically without hard boundaries, to be able to pay for just what you use, to start very small and scale up as you need it, to move away from thinking about individual servers or VMs or how much memory or CPU do you need, and to be able to think just in terms of the capabilities you want to be able to have. To do that globally across any region in the world and drive your needs through APIs as you need them and secure data end to end. These are kind of core characteristics of a real cloud-native data system. And the reason I think this area is so exciting really comes from the time that I spent in LinkedIn. So when we were building Kafka and the other systems inside of LinkedIn, our job wasn't just to build those, it was to operate them as a service and to offer them to different product teams that needed to use these capabilities. And this was a shockingly hard thing to do. At the time, we expected that the engineering of new data systems would be the hard part. But in many ways, it's actually the operations which is much harder. We would joke that building new distributed data systems was what we would use to entice the best engineers to take on the hard problem of at-scale data system operations. And we really struggled to be able to do this in a way that was so reliable you could just count on it, and wasn't a bottleneck to be able to provide new capacity, new systems on demand to other teams. And the reality was we never quite got there. Despite all the effort that we put into it, we always were the bottleneck, the slowest point. Being able to scale and do that reliably, be able to turn over the control to the application teams that were using it, this was always the challenge, and it was a huge investment to do it right. And this was true for all the different systems that we ran. And it's equally true for Kafka. Managing Kafka at scale is hard. And it's not just Kafka. Kafka is probably on the better side of the spectrum of distributed systems, but distributed systems are really difficult. And you come in at the application level trying to accomplish, solve some use case or problem for your customers, and you find yourself getting lower and lower in the stack till you're upgrading operating systems and tuning GC and messing with configuration, all of these low-level things. And when anything goes wrong, there's a problem in the system, and nobody likes infrastructure that has issues. The only good infrastructure is perfectly reliable. There's no need for a system that is down frequently. And I think this really is a bit of a disconnect in how people view the operations of distributed systems. From the outside, it seems like a really fancy job to have. It seems actually quite cool. But when you get into it, there's really quite a lot of toil involved. And despite all the effort in automation that people tend to put in, they never quite get ahead of the curve. They're always struggling through the next upgrade, the next rollout, getting onto the new instance types, whatever the next project is. And nothing in the tooling really changes this, because it is fundamentally a hard problem that I think cuts right to the heart of how distributed systems are built, how they're architected. And there's no one technology that changes this. People think, oh, I know, we'll just put it in Kubernetes, and that will make it elastic and scalable. And I think it's actually a lot more difficult than that. I think it cuts right to the heart of what the software itself does. I think it cuts to the operational practices that are in place. And that's why I think that data systems as a service, the idea of cloud-native data systems where you're really getting a fully managed service, I think that that's the future in this area. And I think it's really an amazing thing. This is increasingly what we see talking to technology teams in companies in all types of industries, from the most technical companies to the least technical. Increasingly, they want to get out of the business of trying to run data systems themselves, and they want to put their best people on the things that differentiate their company. And this allows them to move faster. It allows them to really invest in the things that are consuming these data capabilities, and it allows them to get best-of-breed capabilities out of other systems. And I think that this makes a ton of sense. It wasn't something that we could do at LinkedIn. We were building on-premise in a world where we couldn't have somebody come in and do it for us. But the result actually came with a real cost. We had leadership teams from Google and Yahoo that had built big at-scale operational data systems. But there was a belief internally that we really needed to have about 70 to 75% of our engineering talent working on infrastructure, working on the things that made the people who worked on user-facing products productive. And I think that was right. I think in those days, for the problem we were solving at that scale, that was exactly what we needed. But if you think about what the current state of the world is, what the needs are now, having 75% of your engineering team working on something that only indirectly affects the customer, a means to an end in building new applications, it doesn't really make sense. And increasingly, that's what we're seeing. We're seeing teams move to these data systems as a service. And the infrastructure engineers, they don't disappear. They tend to move up the stack. One of the most interesting things I think about working in software is there's always one layer up. Whenever one layer becomes easy, whenever you can kind of get it in a predefined product or service, another layer appears above it. And so the people who used to work on the big Kafka upgrade or making the configuration changes or rolling out the changes for such and such a use case are now moving into how do we apply event streams for machine learning pipelines, or how do we use it to detect fraud, or how do we drive real-time logistics, which is honestly at least as interesting. And so I think this is a huge change. I think that the move towards fully managed data systems is actually a really positive thing. But it does present a little bit of a dilemma in the world of Kafka. So you might ask, if running Kafka is so hard, then why has Kafka been so successful? Why is it winning? And this is a good question. There are cloud-native services in the streaming space in each of the major clouds. And yet, despite that, Kafka probably has a bigger presence in all of those environments than the native services do. And in most cases, by a really significant margin. And so I wanted to run through why I think that is. What has made Kafka successful? I think the first thing is just, it really is an end-to-end solution. There's APIs to read and write data streams, but also to process and build applications that react and respond and do things with them. I think stream processing really unlocks data. There's an ecosystem of connectors to hook this into other systems. There's the ability to store data for any period of time. These are really important capabilities. But I think maybe more importantly is the community around it. There's hundreds of meetups around the world. Tens of thousands of people attend these meetups. There's a whole set of people who think about how to make Kafka better, how to apply it for different use cases, and are continually innovating around that. And as a result, there's a massive ecosystem of software that plugs into Kafka. And that's incredibly important in this streaming area, which ultimately is about connecting things. And all of this means that the Kafka community has a real point of view on where this ecosystem is going, on what the world looks like in the future, and is building towards that. And I think that's all part of why Kafka has been so popular. And I think part of the reason ultimately is open platforms tend to win. People want to build around an open platform, whether it's x86 or TCP/IP or email or Linux, people want to build around an open standard. And I think that is equally true for Kafka. But because of the importance of cloud-native services, because that makes things so much easier, I think that for Kafka to continue to thrive going forward, there has to be really high-quality cloud-native Kafka services. And that means really bringing together this set of capabilities in the service, really taking the world of Kafka and the capabilities around event streams and bringing it to life with all the capabilities of a true cloud-native offering. And this is something that we've been working on at Confluent. I wanted to talk a little bit about some of the things we've done, some of the challenges in really making a cloud-native Kafka service. And this really starts with, how do you get going? How do you sign up? Can we make this as easy as possible to just get a cluster and start using it, be able to create topics? Can we make that as cheap as possible so you can start with just credits or a few dollars worth of Kafka? I think this is incredibly important. It's easy to overlook how easy or hard it is to start. But since I ran teams that would often spend 6 months or a year trying to get a new data system up and operationalized, to me, the ability to just start quickly with a cloud service, it always strikes me as a little bit like that part of the Matrix where Trinity needs to learn how to fly a helicopter, and she makes a 30-second phone call and kind of downloads it into her brain. I think that's really cool. I think just the ability to get these new capabilities very quickly unlocks the ability to try things out, to experiment, to innovate, and to do it really agilely. But it's not just that, it's the ability to scale up, and to scale up to real size. And so here's a quick video that shows the ability to start with something small and then dynamically scale the Kafka cluster up as it's running to many gigabytes per second of throughput. And this is the kind of project a team might take on a huge amount of benchmarking and hand-holding to get it working in this way. To be able to get this dynamically is really incredibly powerful. And then we've done work to make it possible to scale storage elastically under the covers so that you can just use the system and not have to worry about how much data is on each individual machines or worry about the fact that there's machines and storage at all. You end up paying for just the storage that you use, and this can scale up to petabytes of data, which is actually incredible if you think about it, having a petabyte of stream data in Kafka. And a lot of this comes together under a usage-based model, and I think this is really important. Cloud services, at the end of the day, are an economic model for getting access to data services, to computational capabilities, and so really getting that economic model right. How you pay for it, what you get, making that model fully elastic is critical in really fulfilling the promise of a cloud service. And one of the things I think is most cool in this world is the ability not just to provide something that's better, but actually to do it in a way that's also cheaper. And this is really a cool thing, especially when you think about open source. You think about, well, it's free. But when you really think about the full set of infrastructure and people and time, it actually is a pretty big investment in any data system. But by doing this with real economies of scale, you can make it actually a better deal overall than trying to undertake it yourself and build a team around it. And so that's a little bit of the journey in trying to build something that is truly cloud native. The next area we focused on was really making something complete. I think Kafka is not just a system, it's an ecosystem. And to bring together all those pieces into one offering, I think is a great deal of the power that people want. And this starts with the whole world of connectors to hook up the different systems that you have. And a ton of work goes into this if you're kind of doing it from scratch and building code to integrate with different systems. So making this very simple so you can just say, okay, take streams from here, here, and here, flow them through to there, there, and there. I think this is a huge amount of power to be able to do really quickly. And not just capture them, but actually work with these streams as they appear. So we offer KSQL DB as a service, so you can do real-time stream processing on any of the data flowing through this system using just SQL, which is incredibly powerful. And then we've started to do a great deal of work on how you govern and secure that data. It's not enough to just flow data between systems. Companies care about the quality of that data, the discovery of data, the lineage and flow of data, and making all of this available on a self-service platform. And so we've done work to make schema enforcement possible end-to-end to ensure data quality with different types of schemas from Avro and protocol buffers and JSON and so on. We're doing work that will be coming out soon to make that discoverable. So you can find all the schemas, tag things, manage them, and then be able to reason about the lineage and flow of data end to end. Where does data come from? Where does it go to? Can we audit that and ensure we're in compliance with everything we should have? There's a ton of work that's just going into early access now with customers, and we'll be rolling out across our service globally. And I think this really expands the use of data across a company in a way that's frictionless and correct, and starts to move up the stack into getting high quality data, not just bytes, to all the people who need it. And finally, we've done work to make this available everywhere. For Kafka, this is a system which is providing low latency data streams, and it has to be everywhere your data and applications are. And it has to connect into those different applications and bring this together into one fabric for data streams that spans regions and spans environments. And so we've done the work to make this service available across the major clouds, and also make it available even in on-premise data centers, and be able to link this transparently into one fabric. And so we've done a ton of work in this service on cluster linking. And this allows topics to show up in the clusters of your choosing. It replicates transparently. There's no additional infrastructure that has to be managed. It's purely API driven. And the offsets are exactly replicated in each place. So it's like magic to be able to see your full ecosystem of data wherever you want it in the world across all the different environments, replicated continuously in real time. And this is something that's available in preview now with early customers. And some of this work that we've done for our fully managed service actually spills out to help some of our customers who are running on-premise. And so today, we're excited to announce Confluent for Kubernetes. This is Confluent really designed for the private cloud environment, and it brings some of the same capabilities around elastic cluster expansion, the ability to manage and deploy clusters in a declarative API-driven way, and it brings it to the private cloud. Now, obviously, this isn't a fully managed offering. It's something that you run yourself in a private cloud environment. But we've gained the knowledge of how to build a system like this through the work that we've done to run Kafka at scale for thousands of customers, as well as the work that we've done with folks on-premise who are trying to provide this kind of offering of Kafka on their private cloud. And that's allowed us to really take that and turn it into something we can help companies do this in all of their on-premise environments. And this can connect up into our cloud environment and link transparently to that to really act as one fabric for data streams. And this isn't just about our commercial offerings. There's a ton of work that goes into the core of Kafka itself. And these improvements really trickle into making Kafka world-class. And one of those efforts that we've talked about is the effort to actually remove the Zookeeper dependency. And this is available now in early access in Kafka's 2.8 release. But I think that this dramatically simplifies the operation of the system. It takes us from a world where there was really two things down to one where there's really just one simple binary to execute that gives you Kafka. And the way that we do this is actually, I think, really elegant. We're using the Raft consensus algorithm, which builds on top of a consistent replicated log. And we're actually using as that log Kafka itself, Kafka's log, right? And so we call this Kafka Raft. And the reason that this simplifies things so much is it takes all the duplication between Kafka and Zookeeper, both of which were keeping a log, and the fact that they had two different network layers, two security models, two monitoring systems, two ways of running and configuring each of them, and it gets down to just one. There's just one way to do it. And I think that this dramatically improves the simplicity. And I think that that has a huge impact. If we want to make this something that everybody can use, we want to make it as simple as possible. And it isn't just the simplicity, this also improves the scale. So one of the scalability bottlenecks in Kafka is scaling the number of partitions, and this has two elements. First, the number of partitions you can kind of practically have per machine. There's no hard limit. It can always go up, and more hardware will take more. But also the number of partitions you can have overall. And so this doesn't change the per machine partition count, but it does change the number of partitions that's easy to manage in a cluster overall. And the reason it does that is because it actually moves this metadata local to the Kafka process. And so you no longer have to go remote to talk to Zookeeper. You can do those changes directly by publishing to the Kafka log. The lookups can be done immediately from stored data within the Kafka brokers. And this turns out to be much, much faster and more scalable in managing a larger number of partitions. And so, this is just one of the operations around metadata, the controlled shutdown and the recovery from an uncontrolled shutdown. And you can see how these change. In many cases, it's more than an order of magnitude difference in the scalability that becomes practical in terms of the number of partitions. And I think that this effort to provide a cloud-native offering of Kafka, but also the effort to really reinvent the internals of Kafka itself, to make it scale, to make it easy to use and deploy. I think this is essential to the rise of data in motion, the ability to really apply event streams across every company in the world, to make it possible for this to act as the central nervous system that ties together all the applications and data layers a company has. And I think that project is essential to this larger transition of companies becoming software, of becoming software defined, of being able to drive the interaction with their customers, their back-end operations in systems that connect everything they do and act continuously and in real time. And that's why we're putting this effort into making Kafka cloud native, and that's why I'm so excited to get to talk to you about it. Thank you all so much.